Hey guys, I will be doing problem 700 called search in binary search tree. So problem says that given a root node of a binary search tree and a value, you need to find the node in the binary search tree that the node's value equals to the given value. So we want to return the subtree rooted with that node. If such node does not exist, you should return null. And for example, if the tree looks like this, we want to search for 2. We start with 4. Since um, 2 is less than 4, we want to move to the left side. And now this node is equal to the value. Therefore, we want to return this subtree. But if we want to search for 5, then we start with 4, we move to the right, we go to 7, and if 5 were to exist, it would be on the left of 7. However, there's nothing on the left of 7, therefore we would return none. So this is a pretty simple recursive solution, or pretty simple recursive problem. And if you haven't, I would recommend pausing the video to try this problem if you haven't done already. But let's go with it. So we want to think about the base case. So in the base case, in this recursive problem, is that if the root value is equal to the current value, then we're already finished. And we just want to return the current node. So rather than calling this root, I'll just call this node to make it more general. So if the node, that value is equal to the value we're looking for, we just want to return the node. Great. But now, if the value is less than the current node value, then we want to look left. Otherwise, we want to look right. But sometimes the left node is null, in which case we might call the recursive function with the null value. In which case, let's say if the node is null, in which case in Python none, I just want to return none. So let's see. Now we know that node is not none because I already checked that. So now if the node that value is less than the value we're looking for, then let's see. Let me reverse that. So if the value that we're looking for is less than the node that value, we want to look left. So I want to call a recursive function with the left node. So self dot binary search tree with left node and the same value. And it's okay if the left node is none, because in the recursive function it will return none. But I just remember I need to return the results of this recursive function. So now I want to do the same thing to the right side. So node.right.val. So let's see if this works. So it looks like it works for this example. So this is a recursive function, and we can actually rewrite this to be iterative, because as you can see, in this recursive function, we're always only calling one recursive call. So this would be something considered to be called tail recursion, and we can change this into a loop if we want to. So let me change this into a loop, and I'll have a while. Let me start with while true, and in this while loop, I want to basically keep the same functionality I had before. So I'll do while true, if let me just do this one. So if the node is none, we want to return none. But what we could do instead is we can make that the while condition. So while node is not none, we can keep on doing this. And if we've broken from this results, then we can just return node. Great. But otherwise, we can check if the node is equal to the node.value. If that's the case, then we could break from this while loop and we'll end up returning this node. And now, if the node is less than the node.value, I want to set the node to the node.left so that when we start this while loop again, the current node would be the left node. And otherwise, we want to set the node to the node.right. And at the very end, once we either find a node that doesn't have a left or right, when we're looking for the value, we will break from the while loop because of this condition, or we find the node.value is equal to the value that we're looking for, in which case we'll break from this condition right here. It will eventually return node or undefined, or I guess not defined. So let's see if this works. And looks like it works. Good.